So, running ASP.NET Core apps without a server. What? My name is Isaac Levin. Maybe I should turn my clicker on. My name is Isaac Levin. If you have not heard of me, maybe you've seen some other talks from me. Maybe you've seen me on Twitter. Maybe you've seen me on all sorts of different tech social media because I love the look of my face and I love the sound of my voice. So I'm everywhere. Here, if you do not know about me, you can follow me some of the places here. I also have a podcast called Coffee and Open Source where I interview folks all across the tech landscape. I've interviewed folks like Scott Hanselman, Kelsey Hightower, Martin Woodward, who works at GitHub. A lot of actually folks and speakers that are here at NDC, I've interviewed them in the past. So if you like tech podcasts and people ranting about tech, give that a shot. I appreciate it. So let's get to the topic at hand. How did we used to build web apps? Like not web apps today, like in the past. Like what are some of the ways that you folks here have built web apps? Just shout them out. We're all friendly, right? Oh, you're not gonna give me anything, are you? All right. Well, I'm gonna do the work for you then, I guess. So the web forms era. So who here knows about web forms? All right. Does anybody know, show of hands, or not show of hands, just shout it out, like what the architecture for web forms is? Terrible? Oh. There's a particular model for it. That model is called page controller. So let's talk a little bit about the web forms era at the time. So the time was around 2002. VB6 was slowly dying. WinForms is the way that people were building applications for the desktop. WinForms is awesome because you could drag things from Visual Studio Designer onto a designer canvas, and you could create client UIs really quickly in Visual Studio. Awesome experience. And then the decision becomes, we should have a similar thing, but for the web, right? So Microsoft started to build out what was called at the time web forms, a page controller model, which basically what that means is that you have a UI and you have a code behind. So you have an ASPX and you have an ASMX, right? So what's really important to call about the web forms era is that web forms, from a developer's perspective, was really, really good, right? You can drop things into your pane. You can really have a fast experience developing locally. However, what's one of the big drawbacks for web forms? Performance? View state. View state's back, by the way. What else? Yeah. A lot of stuff was kind of hidden from us as developers, right? Like you drag a control, like a text box control, into your ASPX file, and then like all this HTML would just get generated for you. Great experience, also not that great of an experience if you need to like make any modifications to what that HTML actually gets rendered like, right? So what ends up happening over the course of that 6 years or so, web forms continues to evolve, but it still has these problems that how do we fix the experience? Because remember at this point in time, like the web is still fairly new, right? The idea of building apps on the web is fairly new. And the idea that like, do customers, like end users, they really care like what the page looks like? Like, do they really care? Not really, right? There's not a lot of things out there to make the experience better. But then what happens right after this era? Anyone want to take a hint? MVC? We're going to get there. Focus on accessibility. There's a phrase that's used in the industry a lot that defines the next era. Who here has heard of Web 2.0? Or at least heard the phrase? Don't really know what it means, but are like, I need a Web 2.0 app. Web 2.0 basically means like rich client experiences, client being end user. So like the web page looks nice, HTML, CSS, and JavaScript start to grow aggressively, and people are starting to build really, really interesting things, including some of these things here. I don't know what generation y'all are from. I graduated high school, or I don't know what it's called in Norway, if it's not called high school, and like MySpace was like a really, really big deal. And building MySpace pages was an amazing experience because you could like put your own HTML, CSS, and JavaScript like into your MySpace profile and it would render on the page. Just like a great idea from a platform perspective. Like, let's just run random JavaScript in the browser and see what happens, right? But you had like this feeling of real success if you like your MySpace profile could like crash someone's browser, right? Like just playing copious amounts of weird music, flashing lights, all sorts of crazy stuff. And that is basically like the Web 2.0 experience, using JavaScript, HTML, and CSS to really customize your end user's experience. And like most of the companies or platforms that you see on this slide here are very much still alive today, but were founded during the Web 2.0 time, right? So how does Microsoft and how does the .NET team react to 2.0? Any guesses? Silverlight. Not yet, but yes. They say, let's make JavaScript more accessible inside of web forms. They use the Ajax Control Toolkit. They use the ability to bring they started shipping jQuery in projects, like in the project templates, right? Who remembers jQuery? Who still uses jQuery? Still the best way to write JavaScript apps, by the way. After that, there's a paradigm shift. There were different ways to build apps after Web 2.0. Most notably, like you can build apps completely in JavaScript, SPA apps. Frameworks started to come out that were built on JavaScript. And one of the models from an architecture standpoint that came out during that time was the model view controller model, which, as we all know, is MVC. So Microsoft starts to build a model view controller platform on top of .NET, and that's called MVC around 2008. And that whole evolution is up until about 2014. And what's great about MVC is that something else came along with MVC for the ride that we really don't think about. It just happened to be there, and now we take advantage of it, even still to this day. And do you know what that is? So what does the C stand for in MVC? Controllers, right? What are controllers? Technically, APIs. Web API comes along with MVC in a little bit after, I think it's like version 3 of MVC. And then we have this experience where we can actually like build APIs and applications that have an actual UI in the same way. Like that's an amazing experience for a developer, right? Like the idea of like, oh, I build code once and it runs in a bunch of different states, right? Really cool. And one of the great things too about MVC is that we start to see a shift from XML from a web server's perspective to JSON. All the JavaScript frameworks, they use JSON to pass data, and MVC starts to allow that as well. And what's really interesting is that when you think about MVC, it's still used today, right? Like a lot of JavaScript frameworks still use MVC. Obviously, you can use MVC to build modern .NET apps. But what's interesting in my opinion, with MVC is that it was the first real attempt by Microsoft to build components and build platforms in the open, right? Who here remembers Codeplex? Codeplex was like GitHub before it was cool, right? So Microsoft made a concerted effort to start to ship this code in a public form so people can actually view it. And that's started, and it continues to evolve today. When you see modern.NET, it's all on GitHub and things like that. And we'll talk about that in a second. But the most interesting thing to me with MVC is that if you're still building, like you need that Web 2.0 experience, like you can still take advantage of jQuery, you can still take advantage of JavaScript and all of that, and we start to see those experiences coming into Visual Studio proper. So what happens after 2014? What happens in 2014 that like really is a catalyst in the entire web space? React. Node.js, NPM. JavaScript frameworks, mean applications. And then people realize like MVC kind of stinks to build web apps. because I want to be able to build like really rich web experiences with cascading dropdowns and cool animations, and MVC can't do that because I have to post back to the server, right? Because remember that like all of these different frameworks, web forms, MVC, they all require some sort of interaction with the server. They have to post back, and the server has to send some HTML back, or a request back, response back, sorry. So like JavaScript wins, right? Like around 2014, 2015, like who was a developer around that time? JavaScript won, right? Like there was a point in time where it's like, oh, do we all need to be like Knockout.js developers? I don't know if Knockout was around at that time. Do we all need to be like Angular.js developers now instead of .NET? We use .NET for our APIs, but we definitely don't build front ends with .NET anymore. That's like what like Grandpa did. So what happens next, right? So 2014 happens. Microsoft sees the writing on the wall. They say, hey, like a lot of these web applications that are being built today, they're being built on non-Windows devices. They're being built and deployed to non-Windows platforms. They're running on Mac. They're running on Linux devices, right? That, along with a lot of other things, Microsoft starts to build what they call vNext of .NET and ASP.NET. That eventually turns into something called ASP.NET Core. And who here uses ASP.NET Core today? It's the best thing ever, right? That's right. So that's 2014. So the 1.0 version shipped. A couple years later, the 1.1 version shipped. And then a couple years after that, 2.0 shipped. I was at Build when they shipped 2.0. And I think it was kind of like okay, this is ready. The bits haven't shifted. The bits aren't shifting anymore, really. And you can start building apps in this framework, in this particular way, and be successful. And I think it was the first, other than adding like a jQuery, like JavaScript include in your projects, it was like the first time that like Microsoft starts to embrace these JavaScript frameworks. Like SPA templates are available like out of the box. Like you can create an Angular app that hits an ASP.NET Core backend. And like you don't need to wire all that up. It comes for you in the template. Right? One of the things that's also really, really great about ASP.NET Core is that because of the fact that it's no longer tied to Windows and IIS, it ships with its own web server. That web server is called Kestrel. And why is that interesting? Because it gives you flexibility to do things like create proxies, manage the instances of your web services in a particular way that's really, really valuable to you, right? All at the end of the day, this allows you to be more flexible as a developer because you can build on any sort of platform, deploy it in any sort of platform, and your heart's content, right? So that's to today. However, there's still one problem with ASP.NET Core, like MVC or Razor pages. And what's that problem? But what if I still want Web 2.0? You promised me Web 2.0 like 10 years ago. And now you're telling me like, hey, now you have a cross-platform version of .NET, but it's still not Web 2.0. Like it doesn't give me rich JavaScript experiences out of the box. It doesn't give me the ability to not have to post back. Like what if I want Web 2.0? Well, at that particular time, you had two options. You could use just plain old JavaScript or jQuery, put that in your project, and you could go about your merry way. jQuery is still the best way to build front-end apps, in my opinion. Or you can go the second approach. And what's the second approach? Razor? So Razor is still server-side rendered, right? So Razor is still like a Razor file or a CHTML file for using Razor pages or MVC. Like it still requires a postback. You can put some tricky JavaScript in there to make it not seem like it, but it still does postback. But if you want true Web 2.0 at this particular time, you get to choose your own adventure, right? Who here knows what all of those logos are? Not one person? All right. Class, we're going to do it one by one, all right? What's the green V? Yay. What about the blue and black thing? We're skipping that one. What about the red A? Angular. What about the black N? Next.js. What about the S? Svelte. What about the thing that says Ember? And what about the last one? React. So what's this one? I said it already. Knockout.js. Knockout.js is interesting because it was built by somebody named Steve Sanders. We'll talk about that individual in a second. So if you still want like Web 2.0 experience, you still got to use JavaScript, right? You still got to like be in this constant state of hopping between server-side rendered solutions or by building APIs in .NET and then having to like open up something else because the Visual Studio tooling at the time was opportunistic. Let's say that. You have to spin up like, Sublime Text or maybe, in the last few years, like VS Code, and then you build like your front end, and then you run both at the same time because everybody's got 64 gigs of RAM, and you're happy to an extent, right? But you could be happier, and I think you know where this is going, right? What if you didn't need JavaScript? I'm going to play a video. Funny enough, this video happened at NDC Oslo about 5 years ago. I think it was 2017, either 2017 or 2018. Was anybody here? Yeah? Was your mind blown? Yeah? Has everybody here seen this video? I'm going to show like 2 or 3 minutes of this video. So bear with me. I just realized that I probably need to plug in audio. I need to plug in audio. Am I good to just plug this in? Cool. And if it works and I don't blow out the TV, awesome.
The background, and there we go. Now, if any of you were in my talk yesterday, you may find this to look quite familiar, because it looks the same as the Angular and React and other templates that we've got shipping at the moment. And it's got the same functionality as those do. So we've got basic client-side navigation. I can go backwards and forwards. We've got an example of a component that lets you increment a count, and an example of fetching some data from the back end there. But what does this code really look like then? So let's expand all this stuff, and we will see that it is not React or Angular or anything like that. And in fact, there is no JavaScript in here whatsoever, none. It is just C# and Razor. And what does it really look like? Well, let's have a look at this counter code here. And it's very, very simple and predictable. Okay, I'm using C# to say I'm going to have a count property, which is an int, and then I've got a method that when you call it, it's going to increment that count. I'm using Razor to display the current count, and I've got a button that you can click, and it will increment the count in that kind of way. So that is how that works. And other nice things work too. For example, if I want to change my code, let's change that to counter 1, 2, 3. It's just going to update very quickly. And if I wanted to make it go up in tens rather than ones, then I come back and click that and it will do. Okay? So it's compiling very quickly there, and it does that by having an instance of the Roslyn compiler in memory there. So not inside the browser, but on the server there, we've got a Roslyn compiler that can very quickly produce updated DLLs that can get loaded and run through WebAssembly there. So that's very nice and fast. But would it really be nice for you as a developer to build something like this? What would the actual experience be like? Let's have a go at adding a bit of functionality to this site now. And I'll do the classic example that everybody always wants to do, which is, of course, a to-do list. So I'm going to create...
So we're not going to watch the entire video because you paid to not watch a YouTube video. Basically what Steve Sanderson, who was the person who created Knockout.js and eventually created this particular experiment, which turns into something that most of us have probably heard of, at least based on hand raising earlier. He talked about a particular promise. And that particular promise is the idea of using C# to build Web 2.0 experience applications, and you don't need any JavaScript. If you want JavaScript, you still use JavaScript. It's not replacing JavaScript, but it's giving you the ability to build apps only in C# without having to worry about server side and all of that sort of stuff, right? So coincidentally enough, that particular project was an experiment at the time. It was using something called, I can't remember exactly what it was called, but it was a minified version of .NET that basically was able to run in the browser. I think it was .NET Anywhere. If I'm wrong, somebody in the YouTube comments in the future will say, that was wrong. However, let's move along. So how is this actually able to be accomplished? So who here has heard of WASM or WebAssembly? Who here can give me a pretty accurate description of what it is? Okay. So there was 40 people raising their hand for I've heard of it, but one person who can describe it. So WebAssembly, and I'm going to oversimplify it, so I apologize. It's a binary instruction format that allows you to build and compile applications that are written in miscellaneous languages down to a particular format that can be ran by the browser. That's all it really is. So whether you're building C++ or Rust or C# or Go or what have you, more than likely there's a compiler in most cases that will allow you to take that programming language, that compiled code that you have, and run it in a browser. And that's what WebAssembly does. And WebAssembly 1.0 shipped a handful of years ago, and it's supported in all the major browsers. That's great. Why are we talking about WebAssembly when we were talking about .NET earlier? You probably know where this is going. How do we use .NET with WebAssembly? Well, the answer is Blazor. So just a little bit of backstory on Blazor. So when that experiment, the idea, it was called Blazor initially. And the experiment evolved in a handful of ways. The first iteration of Blazor was what we call Blazor Server, which coincidentally enough is the same development experience, but the way that you get information from the server to the UI was using a WebSocket client or a SignalR client to send the diff of a DOM back and forth. So kind of tricking you into thinking that it's running in the browser because there's no postbacks or there's no anything, but it's still making calls back out to the server. And then there was an implementation of Blazor for WebAssembly called Blazor WASM. And that uses the mono runtime to basically compile your C# application into a particular format that runs in the browser. And there are some positives to that, right? You can run this in very small environments, right? You don't need a server, so you can run them in places that you would not expect them to be able to run. You have access to the full .NET runtime, so you have access to all of the great things that we're used to as we build .NET developers. And there's a simpler architecture in the grand scheme of things because you don't have to rely on some web server technology running on your particular systems. But there are drawbacks, right? For instance, bless you. For instance, you can't have an experience that's offline, right? Because you need to have some interaction with some server or else it's not going to work. There's also latency. There's also size of the project because you're loading the .NET runtime into your app, right, into the browser. And there's server resources that do come along with that because you're going to eventually have to make some service calls. But these are similar cons that you would get if you were to build any SPA app today using React or Vue or what have you. The trade-off is that it's all in C#. And if you want to sprinkle some JavaScript on there, you definitely can, but you don't have to. So why would I do this? Why would I use some new technology? Somebody mentioned Silverlight earlier. Hasn't this already been done before? Why would you use this new thing instead of just using some Web 2.0 experience or Web 2.0 framework that's been around for 10 years? The reason is quite simple. You get access to all the new language features of C#. So there was a talk, I think, yesterday about all the cool things that are in C#. If you didn't see that, please watch it because there's some really cool things that have been in the last 2 or 3 versions of C# that you probably didn't know about. You also have access to the entire .NET ecosystem, which means all of the rich experiences that have been built out in the community, third-party libraries, all those sort of things, right? You might not have that same coverage if you were to look out in different JavaScript frameworks. You also get amazing performance. If you pay attention to anything from the .NET team in the last 5 years, they immediately say performance. 10x faster, 12x faster than Node, whatever the numbers are today. Performance is very, very important for the .NET team, right? Because they understand that in order to, quote unquote, be relevant in the web space, they have to be more performant than all these JavaScript solutions. Otherwise, people will use those JavaScript solutions. You have the experience to build applications, quote unquote, full stack. And I hate whenever we put the word full in front of everything, or like, full stack developer, like that's not a thing. That's just somebody that doesn't know what they're doing in 3 layers. But you do have the ability to like build your APIs as well as build your clients in the same solution using the same programming language, which is really valuable, right? Tools. Like, there are some really great tools to build .NET apps, right? JetBrains is out here talking about Writer. Writer's awesome. Visual Studio is awesome. VS Code is getting really, really good to build .NET apps on. So you have, in my opinion, like the best tool chain to build apps for the web with those tools. And then finally, you have access to 20 plus years of a company knowing how to build apps for the web, right? Don't disregard that experience. Like, some think mature or stable, those are like not okay things. I definitely would rather go down the path. If I'm building an app today, I'd rather build something that's stable and mature than something that's like the new hotness. Like, I showed a bunch of the new hotness, right? And some of you didn't even, like, Knockout's like the oldest one and you don't even know what it was. So these are some of the reasons why it's advantageous to use Blazor. But what actually comes for the ride when you use Blazor? These are some of the things you get. I'm not going to go over every single one of them because obviously you folks can read. The biggest things to me are things like AOT compilation. So the model runtime allows you to use ahead of time compilation. And to oversimplify it, it basically allows you to have very, very, very small application packages, right? Very, very performant. There are some limitations today with AOT compilation, but the .NET team is putting a lot of effort into making sure that those are very minimal. Like, one big thing is, like, if you want to build an app today and you want it to be AOT compiled, you can use reflection. So if you use reflection today, you need to use something like source generators or some other mechanism to be able to get that same sort of functionality. So if you're building apps today that use lots of reflection, AOT might not be an option for you. Another thing that's really, really great is hot reload. So, like, I think we've all seen demos of hot reload. Like, I'm currently debugging my app. It's running in Visual Studio. I make some changes to it, and then I hit a button, and I don't have to rebuild, recompile. My app just like changes, right? Like, that's an amazing experience, and that's one of the things that you get out of the box of Blazor. Also, the ability to have like really rich interop between JavaScript, like C# classes calling into JavaScript, firing JavaScript functions calling into C#. Like, that interoperability is really, really valuable, because in the situation where we do need JavaScript, we want to make sure that it's secure, right? So the ability to have those rich experiences is really, really valuable. So the question then becomes, all right, Isaac, the name of your talk is like running ASP.NET Core apps without a server. What? So what are some of the options? I imagine most of you folks have probably seen like some other sessions that talk about this directly. But let's talk about some other options other than like static web apps, because I think that's the one that a lot of people think of immediately. What about Azure storage? Like, who here uses Azure in their day-to-day? All right. Who here uses like Azure Blob Storage in their day-to-day? All right. Who here knew that you can like host Blazor apps in static storage today? All right. Less people as I went forward. That's good. Means that people are learning something new. So basically how it works is you can take your Blazor app, your Blazor WASM project, you can publish it, and then you can take those published bits, which are static files. So HTML, CSS, JavaScript, and some DLLs. You can take that published folder and you can put it in Azure Blob Storage, and then you make some small configurations to Azure Blob Storage, and immediately you have a website running in Azure Blob Storage. So that's really, really awesome. And let's actually take a look at what that looks like. So I am in, let's open this up. I am in a command line. And the folks in the back can see this okay? All right. So I'm going to .NET new, a Blazor WASM project, and I'm just going to call this NDC. So basically what this is like the template for a Blazor WebAssembly project. It's nothing special. We can take a look at what it looks like after it restores all the packages. So let's go in here, NDC, and then I'm just going to open up Code Insiders, and then I'm going to .NET run this. So basically what I'm doing here is I'm just running the application. So the application, it's going to look like, if you've built a .NET app in the last like 4 years, it's going to look like the one that you've all seen. But one thing that's really important to call out is that everything runs in the browser. So this is the app. As you can see here, there's a counter. This is very similar to what Steve Sanderson showed a while ago. But there's a counter, and there's no postbacks going on here. And there's flipping between the routes. But if I take a look, let's go over to VS Code real quick. If I take a look at the project, and I look at the bin directory, I have a www root, and I have some DLLs. However, let's stop this, and let's just do .NET publish, and let's just set the configuration to release, and then let's set the output to publish. So all I'm doing here is I'm just publishing this Blazor WebAssembly project to basically to a state where I can deploy it to other environments. And if I take a look at that after it's done, which it does take a little bit of time, let's open up this publish file. It's done. All right. So let's take a look here. So this is our www root. So inside of here, we have a CSS file. We have HTML. I can zoom in a little bit here. We have a framework. We have CSS. Let's take a look at what's in the framework folder. So I'm not going to scroll the way down, but as you can see, there's some DLLs, and there's like this .NET WASM, which is the .NET runtime for WASM, and then there's a couple of JS files, blazor.webassembly.js, and that's the magic. So the blazor.webassembly.js basically takes your .NET.wasm and your other files for your application and basically transpiles it into bytecode that it can run WebAssembly. So that's the quote-unquote magic of it. So if you were to go home today and you were to create a new Blazor WebAssembly project and you were to do this thing and you wanted to play around, you wanted to see like what some of these things did, like for instance, if I opened up this JSON file here, like obviously you can't read it, but and you can actually take a look at the GitHub repo for it because it's all available and free on GitHub. You can see what's actually going on here. But the long and short of it is that this does all the work to get your apps to a state where you can run them in places where you don't need a server. So the question then becomes, okay, so how do I go to Azure Static Web Apps? So I'm in the Azure portal, and I'm using dark theme because somebody told me that light theme sucks. What I want to be able to do is I want to take this this Azure storage account, and I want to make it host my Azure Static site. So if I scroll down in the data management section, right here, there's a static website section. And if I click on that, it's going to walk me through a really quick experience to basically do just that. I can enable static websites, and I can specify the document. So in this particular case, I'm just going to have it be index.html for both. And I put a slash in there when I didn't need to. So, and then after that, I save. And then what's going to do is it's actually going to create a container in my Azure storage account, which is optimized and configured for that static site. And then I have a primary endpoint and a secondary endpoint. So if I go up to storage browser and take a look at my blob containers now, I now have one for web. And I can then upload all of that stuff. Let's just go here, dev, demos, NDC, publish, www root, all of this stuff. And I can drag and drop this directly in here. Oops, not like that, Isaac, you idiot. Right in here. I am failing miserably. Hold on. Open this. Do this. Drag this here. All right, and then it's going to take all those 126 files and it's going to upload them to that container. And once that's done, after a very, very quick amount of time, after I click upload here, it will actually allow me to go to that endpoint that I specified earlier. Once this is done, these are all queued. Make sure they're all actually uploaded. I think this gives you an up here at the top. There, successfully uploaded. So then I go back down to that static website section, and I can open up this primary endpoint here. So I open that up, and then hopefully, ta-da! We have a .NET application running in Azure Blob Storage. And then to take this one step further, I can put this in front of a CDN, and I get all that great experience from a CDN, caching, all that great stuff. The question then becomes, okay, this is cool, but like you need a web server, right? You can configure this to hit an Azure function, or you can configure it to hit, any web service, external API that you have. The interesting thing about doing it this particular way is that Azure storage, in the grand scheme of things, is very, very inexpensive. So if you have an application that doesn't need like a lot of computing, an option to host in Azure storage is very, very interesting. All right. Did you know you can do that? You learned something today. Congratulations. All right. Moving on. The next one is definitely more interesting. So who here has ever played around with GitHub Pages? For the folks that aren't raising your hand, I highly recommend using it because it's free. There's not very many places that you can get free web hosting, right? Even though it's static. But you can actually take a Blazor WebAssembly project and run them in GitHub Pages. And how you do that, there's a few ways you can do it, but the way that I think is the most stable from a workflow perspective is using GitHub Actions. And I assume there's some talks here on GitHub Actions at NDC. If you want to learn more about them, check those out. But basically what GitHub Actions allows you to do is it allows you to configure CI/CD for GitHub Pages. So basically you have a YAML file that defines your GitHub workflow, Actions workflow. And inside of there, we'll take a look at what it looks like. It configures the build, the publish, and the configuration needed to set up GitHub Pages. And all that's done for you. So let's actually take a look at what that looks like. Hop over to my browser, close things that I'm not paying attention to. All right. So here I'm inside a GitHub project that I created last week. And inside of here, if you look, I already have GitHub Pages configured. So I can go over here and I can open this if I wanted to. One of the things that I've done is I've configured a GitHub action to actually build and deploy this Blazor WebAssembly project, which is the same thing as I did earlier, like the Blazor WebAssembly project starter template, so nothing super exciting. But I configured it to basically every time I do a commit, it does a build and a publish, and then it stages it out to GitHub Pages. And how I'm doing that is by using this workflow file that I have defined here. I'm specifying my .NET version, which is 8.0, and I'm making sure the .NET quality is preview. I'm glossing over a lot of the GitHub Actions stuff, so if you haven't had any experience with GitHub Actions, you can come up to me afterwards and we can talk a little bit about GitHub Actions. But basically what I do is I .NET publish my Blazor GitHub Pages.cs proj, and I specify a release, so that's the configuration for it. I also need to do a couple of things to make it work in GitHub Pages, specifically around making sure that a 404 redirect sends somewhere. So I'm just basically doing the same thing I did with Azure Storage, where, okay, the 404 just redirects to index. And then I'm also basically remapping the base of the actual website to be a particular endpoint, because GitHub Pages routes things differently, because he actually uses your GitHub repository as basically the file system for your actual static site. And then I add some configuration for Jekyll, because GitHub Pages uses some Jekyll for that, and I specify the folder for that. So the long and short of it, if I go and look at my particular environment, I see I've done some deployments. I click on a deployment, and then I had that same experience, right? And if I wanted to, I had that same experience. If I wanted to, I can actually use GitHub to make changes to my project, and then when I do a commit, it'll kick off that workflow and do all those things. So let's actually do that, because why not? So who here has heard of like GitHub.dev? GitHub.dev is really, really cool because basically it allows you to like update and modify like multiple files in a repository without having to do like a clone. And it's free, like it's not like CodeSpace or anything like that, it's completely free. So what I want to be able to do is I'm just going to make a modification here. So instead of hello world, I'm just going to change this to hello NDC Oslo because I'm boring. So as you can see here, it says, okay, you have some changes to your index.razor file, and I'm just going to have this say updates, if I could spell. And then I'm going to commit and push those changes. So when I do that commit and push, if I go back to my repository, a GitHub action got kicked off. And we'll take a look at what that GitHub action actually does. So we saw the definition of it. So inside that build step, it's going to walk through all of those individual steps that I defined earlier. So it's going to do a .NET publish, or a .NET build, a .NET publish. It's going to remap the base for all of our static files. It's going to create an 404 that's copied off of index. And all this does take a second, but at the end of the day, it's actually going to deploy it to GitHub Pages. And how it deploys to GitHub Pages, it actually creates another branch in your repository called gh-pages, and that is actually the branch that is used as the file structure for GitHub Pages under the hood. So if you ever use GitHub Pages and you're like, well, how does this actually work? If you go to your branches, you'll see like, oh, there's this GH Pages thing that I didn't create. It gets created for you by default when you configure GitHub Pages for your repository. So in this particular case, so this is doing that .NET publish. Hopefully this does not take too long. I'm going to stall. Actually, let's do this. Instead of stalling, I'm just going to go back to the presentation, then we can hop back here in a little bit. So that's Blazor WebAssembly to GitHub Pages. So that's kind of cool, right? Did you know you could do that? Awesome. Well, this guy's really, really good at his job. He's like raised his hand to every single question. It's awesome. So we took a look at that demo, but there's still a problem. Like, what if I need like really, really fast, iterative developer experiences? I really need fast request response, interactivity with the server. What if I need an interactive design? What if I want Web 2.0? Because that's what people told me 20 years ago was really important. And what if I need the flexibility to navigate between the both? What is the problem with Blazor WebAssembly? Let's just call it out. What if I was to like take like an e-commerce site or a marketing site and use Blazor WebAssembly or any JavaScript framework, and I try to host that? What's going to happen? What's the number one problem? It's not SEO optimized, right? Meaning that if you look at like the actual rendered source, when the actual index.html page is loaded, it's like JavaScript and an empty HTML body, because the JavaScript basically hydrates all of the DOM for you. Really, really bad for search engine optimization. So, but what is the benefit of some of the more legacy technology we talked about? Web forms, MVC, Razor pages. What's the benefit of those? It's server-side rendered, which means that all of the UI and HTML is passed on the request from the server to the client, which means that when you right-click, inspect, and look at the web page, it's the entire HTML. Great for search engine optimization, for instance. So the question becomes, like, what if you need the server-side rendering experience of MVC and Razor pages, but you also want Blazor? You're stuck, right? You're like, oh, I got to go back to like JavaScript. In .NET 8, Blazor is now going to ship with server-side rendering built into it. So you can easily configure or have it dynamically switch depending on what situation you're in, from server-side rendered to non-server-side rendered or client-side rendered. So it's like the best of both worlds. So that's coming out in .NET 8. If you want to play around with it, I don't have a demo for it. The preview 3 of .NET 8 has this in here. So you can actually go out today and get a Blazor server application that renders server-side. So really, really cool stuff. Let's go back to this GitHub. Oh, it's done. So let's check a look and see if our change actually happened. So GitHub pages, 2 minutes ago, view deployment. Hello, NDC Oslo, so it works. So you make a subtle change to your code, and then after that GitHub workflow triggers, you have a site that's updated. If anybody's been doing CI/CD, they're like, okay, cool, you just showed me a CI/CD. That's pretty boring. So the question becomes, like, what are the possibilities now? Because we can now build completely C# projects that have Web 2.0 experiences, but they're also server-side rendered. And you can configure them based on your environment. And Steve Sanderson has a really good video. I'll be sure to put a link to it. At the end, there's a QR code, and I believe there's a link to like a demo that really shows like how you can configure it and what use cases it makes sense, right? So that's my talk. I hope that you learned a little bit something about Blazor WebAssembly. If you didn't learn about Blazor WebAssembly, at least you enjoyed the history lesson of .NET over the last 20 some odd years. If you want to learn more, you want to chat with me about Blazor WebAssembly, .NET in general, you can find me on Twitter, Isaac R. Levin, or some of the other places that I linked earlier. And that's my time. I want to thank you so much for hanging out. I do have limited stickers up here if that's your jam. Thank you so much for having me. It was a pleasure. And I hope you enjoy the rest of NDC Oslo. Thank you so much.